Hello, my name is Anjana SAKHARE and my PeopleSoft ID is 2394214. Today, I will present my project on analyzing and forecasting of the construction investment trends in Japan. This study analyzes and forecasts the trends of the construction investments in Japan. These trends analysis would be useful for helping the government, industry leaders, and the investors to make the better decisions. So here is the table of the content. So it has lot of contents that starts with the abstract, the overview, the problem definition, the literature review about the data set, the data processing, the data exploratory data analysis, feature engineering, model building, and the evaluation continued with the results and discussions, conclusion, and the references. So, firstly, I would start with the abstract. So, the study of analyzing and forecasting trends in Japan construction investments is introduced in this abstract. This project it aims to research past patterns, analyze the sector contributions, and make very accurate forecasts about the future investment tendencies. This is usually done with machine learning, random forest models incorporated with the statistical models like the Sarina. This study it usually bridges the gap in conventional trend analysis and it implements modern techniques. So next I will give a brief discussion and or the description and talk about the obstacles that we have faced here. So the this overview slide it sums up the main features of the project. This project main goal are to predict the future trends, understand contributions across the different sectors, and analyze the past investment trends as well. This study it usually implements both machine learning and the statistical techniques to give the greater accuracy. The significance of this is to support sustainable development in the construction sector. Coming to the problem definition, the slide with the problem definition, it is emphasized with the trouble spots faced while analyzing construction investment trends in Japan. A few important concerns it usually would include understanding past patterns, the thrust of the contributions by the private and the public sectors on the investments, and predicting the future with high accuracy. The ultimate objective it usually becomes better analysis for the constructive decision making. So coming to the literature review, various methods by which private and the public investments impact construction patterns are described, while machine learning techniques such as the random forest are better than others for forecasting. ARIMA like models are rather helpful for the pattern detection. Many of these concepts it's elaborated upon in the study to watch for better forecasting and the trend analysis. This data set it usually consists of annual figures for the total expenditure by the government, civil engineering, private, and the architectural sector of the building. Your total amounts by each sector and the type of funding source are important specifications here. Analyzing this data serves to outline how the massive contribution and the focus of the private and the public investment it changes over the years. Such a background make for the better understanding and predictive ability regarding the investment trends in the building industry in Japan. Coming to the data pre-processing, some of the missing values were found in the pre-processing of the data. So these were handled through forward filling with some gaps filled with the zero and the rows containing large missing data are omitted. Here I appended additional features to the regression models, example the year number and the modified data types to improve the analysis. Through this process, the dataset was ready for proper modeling and the analysis as well. The next one is the exploratory data analysis. So the government it contributions it dominated more civil engineering while the private investments it concentrated on the architectural side according to the EDA, which also indicated investment trends throughout the time. To examine the data and to find the patterns, I used heat maps, the bar charts, and the time series plots as well. The outcome is that the private contributions are primarily concentrated on the architecture, whereas the government investments it leads in the civil engineering. Coming to the feature engineering, to improve the regression models, new features such as the year num were developed in the feature engineering. I developed criteria such as the temporal qualities and the variations in the total investments to reach the stationarity. The modeling is usually done by model. Coming to the model building, I divided this data into 80% training and the 20% testing, and I used regression models like the linear regression and the random for forest for predictive analysis and the Sarima for the time series forecasting. The random forest had the best performance overall, but it ran the danger of overfitting. Whereas the Sarima successfully it captured seasonal patterns with um, an R square of 0.999. The random forest it demonstrated its ability to effectively capture nonlinear interactions as well. Coming to the model evaluation, here I chose the three models for the evaluation. The first one is the Sarima, the second one is the linear regression, and the third one is the random forest. So the Sarima successfully captured the seasonal trends with an MAE of 65,478.43, while the linear regression was much simpler and yet very accurate. The R square with 0.999, it gave random forest the best performance, though there is still a need to keep an eye on the risk of the overfitting. This is all about the model evaluation. So, coming to the results and the discussion, it follows that the finest performance was definitely the random forest, whereas the linear regression was quick and the clean one. Finally, Sarima has also performed well when applied to the seasonal trend interpretations. Looking at the government spendings can change the game in favor of the civil engineering, but the private investments it came out as a more dominant catch in the architectural side. So finally, for the conclusion, this leads to the conclusion that the study effectively used advanced methods to forecast investments and to examine the trends. These results it provides useful information about the Japan's construction investment patterns. This project it shows the effectiveness of integrating machine learning and statistical techniques to tackle complex economical issues as well. So here are the references that I have used for this project, and thank you.